Okay, so we are still in section 12.1, but in this part of section 12.1, we're going to focus on doing some calculus. Yay! We're going to take derivatives of conic sections. So we're going to start with parabolas, but for the whole of chapter 12, when we're doing all of these conic sections, we're going to do derivatives in each section. So the way that we do derivatives is a new kind of way of doing a derivative or finding the derivative. It's what we call implicit differentiation. Implicit differentiation. So right now I'm going to teach you implicit differentiation. We're going to use it for the next 3 sections. Okay, so until this point, we really have only done what's called explicit differentiation. In explicit differentiation, you have y equals, and then you're told what y equals. And when you do explicit differentiation, you can say y prime equals, and then write the answer. It's all explicit. What's new and different is that we don't have y explicitly solved for. We don't know exactly what y equals, and we can't solve for y. So look at this example here. X squared minus 2xy plus y to the third equals 4. My question is, what does y prime equal? What is the derivative of y? Well, how am I supposed to know? Because I don't know what y equals. It turns out you can still find the derivative of y even if you don't know what y equals. All right, now here's a little bit of an aside. We need to talk about, because we're going to do this derivative, and the way we do this derivative is we're just going to do it piece by piece. When you get to a piece that has y in it, what will the derivative of that piece be? What's the derivative of y? Well, I will tell you, it is not the derivative of x. The derivative of y is not the derivative of x. Look at what we did earlier. We had y equals x squared. When I did this, I called the derivative y prime equaled to x, right? And that's because it's really important to notice there's a difference between the letters y and the letter y and the letter x. This letter dy prime, it also means dy dx, and this is a good time to think about the derivative as dy dx. And that's all because of the fact that y is the dependent variable. Y is the dependent variable. Its value depends on the value of y. And so when I take the derivative of y, I get dy dx. And that's also what we shorthand to y prime. However, x has a different derivative. The derivative of x is 1, because if I take the derivative of this, the independent variable x, I get dx dx, right? I d dx x. Well, dx dx is just 1, okay? So in this example that I wrote, in this example, let's do this example here. All right, so I'm going to take this. I know we're all over the place. Sorry. Going back down to the bottom here with my example question. And I'm going to show you how you do the derivative of this piece by piece. And as we do this, we're going to keep in mind that the derivative of x is 1. But the derivative of y is y prime, because that's dy dx. Okay, so x squared, here's my example question. X squared, I know the derivative of that. I just wrote it down. It's 2x minus. Now let's talk about this piece right here. I'm going to do the derivative of this piece in blue on the side. I have minus, actually, let's think about this as plus negative 2xy. So I have negative 2xy. This is a product, right? It's a product. I'm going to think of the first term, f, as negative 2x. And the second term, I'm going to call y. So I'm going to use the product rule here because I have a product. Remember the product rule? Okay, so with the product rule, you label one piece of the product f and the other piece g. You find f prime and g prime. All right, what's the derivative of y? Derivative of y is y prime. And now I follow my product rule, f prime g plus fg prime. And so f prime is negative 2, g is y, f is negative 2x, and g prime is y prime. So it turns out that the derivative of that next term here, which I've made blue, negative 2xy, is what I got right here from the product rule. So I'm going to write that up here. So I get plus negative 2y minus 2xy prime. All right, now the last thing is, what's the derivative of y to the third? Well, the derivative of y to the third is going to use the chain rule. Okay, I know the derivative of u to the third in chain rule form is 3u squared times u prime. Same thing for y to the third. Y is not x, so the derivative is 3y squared times the derivative of whatever y is, which is y prime, not 1. Equals, and now I do the derivative of 4, and the derivative of 4 is 0. Okay, and so I have this big mess here. Let me rewrite it. I have 2x minus 2y minus 2xy prime plus 3y squared y prime equals 0. And the question is, what is the derivative of y, or what is y prime? So I need to solve for y prime. And the way I'm going to do this is I'm going to keep everything with y prime on the left, and I'm going to take everything else, which are these two things, over to the right side. So that's, if I add 2y to both sides, and I minus 2x from both sides. Then, now that I have all my y primes together on the left, I'm going to factor out the y prime. And I have left negative 2x plus 3y squared. Now I can divide both sides by this negative 2x plus 3y squared, and I'm all done. 2x, negative 2x plus 3y squared. And so my answer is, what is y prime? Well, y prime is 2y minus 2x divided by negative 2x plus 3y squared. All right, so on this page here, I have the steps that I just took for implicit differentiation. So the way you do implicit differentiation, take the derivative of every term you see. Okay, don't forget that the derivative of y is y prime. And also, don't forget your product, quotient, and chain rules. Then this is how you solve. You put everything with y prime on the left, everything else on the right, factor out y prime, and divide. So write those down, and then I have some more examples. Okay, so in this next example, this is a parabola. Y squared equals negative 2x. So I'm going to take the derivative of y squared. That's 2y. And then wait a minute, y has a derivative. Its derivative is y prime. This is the chain rule, where I did the power rule, 2, and I subtracted and got 1, so 2y to the 1 times the derivative of the inside. This is my inside. And the inside is y, its derivative is y prime. The equals just comes down, and the derivative of negative 2x is negative 2, just like normal, because those are the x's. And now to solve for y prime, I just need to divide both sides by 2y. And so I get that y prime equals, looks like I get a negative 1 over y. Done. All right, next example here. X minus 3 quantity squared equals 6 times y plus 1. So this is also a parabola, right? This parabola opens upwards, and the p is 6 over 4 or 3 over 2. And your vertex is negative, or 3, negative 1. Okay, but I don't want to know about the parabola. I want to do the derivative of this. So I want to know what y prime is. So I'm going to do the derivative of the x minus 3 squared part. So that's 2 times x minus 3 to the 1. And then the derivative of my inside is 1. Equals 6 times the derivative of y plus 1, which is y prime. Plus 0, because the derivative of 1 is 0. And now to solve for y prime, I just need to divide both sides by 6. So it looks like I get y prime equals 2x minus 3 over 6. And that reduces to x minus 3 over 3. Okay, one last question. This used to be, we used to do these all the time. They're my favorite questions, right? Find the equation of the tangent line. And remember, tangent lines and all lines you can find with point slope form. Y minus y1 equals m times x minus x1. And the way this works is it's a form, and you fill in the x1, y1, and the m. They already told me a point, so there's my x1, y1. I'm more than well, I'm halfway there. So y minus 4 equals m, x minus 11. The only question is, what in the world is the slope? So how do I find the slope? The slope is dy dx, or y prime. So I just need to find the derivative, and then I need to plug in the point 11, 4. Okay, so let's find the derivative of this. The parabola is y squared equals 2 times x minus 3. So I'm going to do the derivative, but I have to do implicit differentiation. The derivative of y squared is 2y times y prime. And the derivative of 2 times x minus 3 is just 2 times 1, 2. So it looks like y prime is 2 divided by 2y. My 2's cancel. And so y prime is 1 over y. This is going to be my slope, but I got to use my point. So m is going to equal 1 over y, and y was 4. So it turns out the 11 doesn't even matter. And now I'm done. I just need to fill that into my form. Y minus 4 equals 1/4 x minus 11. There is the equation of your tangent line. And I believe that's it. Yep, all done.